Dear students, today we will discuss on conformational effect in a 6-membered ring containing unsaturation. We have example that is a cyclohexene, and cyclohexene we have already discussed the conformation in cyclohexene. In cyclohexene, it is occurred in a chair form mostly because it is a stable form. But in a cyclohexene, it is not occurred in chair form, because when it try to occur the chair form, there is double bond is the chair form. It's very strange situation. Okay, therefore it's not takes from the like that chair form, because strain is produced due to unsaturation present in cyclohexane ring, because it is having the sp2 hybridization and sp2 hybridization, and this is the trigonal. sp2 hybridization is a trigonal hybridization. Therefore there is a strain is produced when cyclohexane takes the form of the chair. Therefore it's not occurred in chair form. There is a distortion in a chair form takes place, and it's looking like that. Double bond is here. Axial and the equatorial, that is the equatorial and the axial dash and the equatorial dash, axial dash and the equatorial dash. Okay, this is a distorted chair form. Okay, it is distorted from chair conformation, which is occurred in a cyclohexane, which is not contain the any unsaturation. Okay, therefore if you give the naming 1, 2, 3, 4, 5 and 6. Okay, we have some observation for this form of the conformation. In this these double bonds hydrogens are the ethylenic carbons. Okay, these double bonds are the ethylenic carbons, and like that C is there, and this carbon, if double bond next to the double bond, that carbon is we called as the allylic carbon. Okay, therefore these two are the first we have observed C1 and C2 are ethylenic carbon. Okay, ethylenic carbon means it is a C double bond C, and the C3 and C6 are allylic carbons. Okay, the carbon number 4 and the carbon number 5, it is having equatorial, perfectly equatorial and the normal equatorial and the normal axial. In 5 number carbon also normal axial and the normal equatorial hydrogen is there. Okay, therefore at carbon number C4 and C5, the hydrogens are normal, axial and equatorial, as like which is present in a cyclohexane. Okay, as like cyclohexane. Okay, in cyclohexane the equatorial and the axial position, are maintained in carbon number 4 and the 5. Okay, that is perfectly, it is axial and the perfectly equatorial position is taken carbon number 4 and the carbon number 5. Okay, and these are perfectly staggered. Okay, it's carbon number 4 and carbon number 5 carbon hydrogens are perfectly staggered to each other. Okay, staggered conformation you can show like that. Okay, this carbon when you take, in this case equatorial is there, axial, okay, normal axial position, and then this bond. Okay, now backward to this carbon there is a axial is there, normal axial, normal equatorial is there, and this is that side. Okay, therefore carbon number 4 and 5 are staggered to each other. Okay, now carbon number 3 and 6, carbon number 3 and 6, the hydrogens are imperfectly axial and equatorial. Okay, and it is imperfectly not staggered to each other. Perfectly, it is not staggered perfectly to each other. Okay, due to this strain, these hydrogens due to strain, it's not takes the perfectly axial position and the perfectly equatorial position. Okay, and our last observation is the carbon number 3 and 6, and that is ethylenic that is allylic carbons, and carbon number 1 and 2, that is carbon number 1 and carbon number 2, that is ethylenic carbon, that is double bond carbon, are present in one plane. Okay, these are the, in single plane you observe that carbon number 6 is also present there, that is allylic carbon, then carbon number 1, then carbon number 2, that is both are the ethylene carbons, and third one is the carbon number 3, it is allylic carbons which are the present in a single plane. Only these two get the away from or distorted from away from each other. Okay, and in this case you found that the carbon number 3 and the carbon number 6, this axial is not perfectly axial position, which is we have seen in the cyclohexane, and in this carbon number 6 and the carbon number 3 both are not the perfectly axial and the equatorial, and carbon number 6 when overlap from this side to 6, then in this case also these are not perfectly staggered to each other. Okay, due to it's not perfectly axial and the equatorial, these two are not shows the perfectly staggered to each other. Okay, this is all about the when double bond is present in a cyclohexane ring, then this conformation will be found there. Okay, due to avoiding the string double bond fruits. Okay, that is sp2 hybridized carbon, it's a trigonal planar, therefore for avoiding this the cyclohexane molecule takes that in the form of that conformation where 6, 1, carbon number 2 and 3 are present in one plane, and out of planes carbons are 4 and the 5. This is all about the conformations when double bond is present in cyclohexane ring. Okay, now the carbonyl groups in a cyclohexane ring Okay, that is a cyclohexanol. Okay, like cyclohexanol. So that is, we have to interested in the 2-alkyl keto effect. In this case, if there is R. Okay. At 1 and the 2 position, at 1 position there is a carbon, and in this case at 2 position there are the alkyl group is the attached. Okay. These alkyl groups and carbonyl groups are overlap to each other. Okay, when you see from this side, you found that this carbonyl and this equatorial groups are overlap to each other. Okay, therefore the interaction between this R and carbonyl group is present there. Okay, the interaction between carbonyl and alkyl groups present. Okay, due to this interaction, okay, perfectly overlap. When you see this molecule, show this molecule in staggered form, you found that the from that carbonyl is like that, the second groups is like that, and there is no hydrogen is there, and behind there is you have found the R group is there, and this is our group, and is the hydrogen is at the top, acyl hydrogen is there, that is acyl hydrogen is there, and this is the groups. Okay, like that. Okay, when you show in like that conformation, you found that carbonyl and the alkyl groups are overlap to each other. Therefore, due to this overlap, it produces the interaction, and that interaction is called as the 2-alkyl keto effect. And due to this interaction, the energy of this molecule when R is at equilibrium at the equatorial, then the energy of this molecule will increases. That is, the interaction between carbonyl and this R group takes place because these are the exactly overlap to each other, and due to this interaction they try to repel to each other. Okay, that adjust to each other. Due to this there is a interaction is produces, and that interaction is called as the 2-alkyl keto effects, and it increases the energy of that molecule. Okay, now we have 3 molecules. Okay, first for the study of the 2-alkyl keto effect, first molecule which is having CH3 is at equatorial. Second, it is having CH2 and CH3, that is ethyl group at equatorial. And third molecule which is having the isopropyl group at the equatorial position. Okay, 1-2 position. Okay, we found that in this molecule we have increases the bulk at the equatorial position. Okay, at 2 position equatorial, in this case CH3 is there, CH2 CH3, that is ethyl group is present in this case, and in this case isopropyl group is present. Okay, bulk is increases at the equatorial position. And we have found that, okay, some energy is produced. We have studied the due to 2-alkyl ketone effect, there is interaction is there, carbonyl and the alkyl group, therefore the energy of that molecule gets increased. Therefore, in this case, when this molecule you compare with the, if it is acyl one, okay, in acyl one there is a 1,3 interaction is there, okay, this is interacted to this, okay, therefore its energy is no doubt is the higher than this, okay, but this molecule produces the some interaction and its energy is increases to some kind energy is increased due to these interactions, okay. When you take the difference between these two molecules, energy difference between these two molecules, you found that it is 1.6 kilocalorie per mole for these two molecules. And the difference between these, okay, we have the second molecule, that is our CH2 and CH3 is at equate acyl position. The difference between these two molecules will be 1.1 kilocalorie per mole. Okay, it means its energy gets, its equatorial ethyl molecule energy gets increased. Therefore, the difference between these two gets a decrease. In third case, the difference between the acyl group, okay, CH is not CH2, CH3. The difference between these two groups energy is 0.4 kilocalorie per mole. Okay, therefore difference get decreases. It means difference decreases means the when you increases the bulk at the equatorial position, then 2-alkyl keto effect is increases. The interaction in these two groups increase because a large group is there and the interaction due to increases energy is increases. Therefore, the difference between these two get the decreases. In third case, it's also it's very bulky group is there. Okay. Isopropyl group is the very bulky group. Therefore, it enhances the 2-alkyl keto effects. Therefore, energy is increases. Due to energy increases, the difference between these two molecule will be 0.4 kilocalorie per mole. Okay, therefore, as your bulk increases, you found that the energy of this molecule increases. Okay, energy increases means what? Unstability is increased. Okay, in this case, difference is 1.6. Okay, it's not in this case, the effect is the negligible. Okay, effect is the negligible. Okay, large difference is there. Okay, it is higher energetic and its energy is not much more increases. Okay, due to this methyl group. Therefore, differences is the high in this case. Therefore, in this case, when methyl group is there at 2 position, the 2-alkyl keto effect is found negligible. For this case, you increases bulk at the equatorial. Therefore, the 2-alkyl keto effect is increases and molecule gets unstable and its energy is increases. When molecule gets unstable, gets its energy is increased. Therefore, by comparing with this, its energy definitely increases. Therefore, the difference is the decreases 1.1 kilocalorie per mole. Okay, and third situation, you found that it's not much more difference is there. Okay, at acyl position, only 0.4 energy is higher than at the equatorial position. Therefore, as bulk is increases at the 2 position, the 2-alkyl keto effect increases and it is found significant when at equatorial ethyl group is there and isopropyl group is there. It found the significant effect. But for the 2-alkyl, if some methyl group is there at 2 position, the effect is not found much more as like the which is found significantly in the when ethyl group is there at 2 position and the isopropyl group is present at the 2 position. Okay, this is our 2-alkyl keto effect which is found significantly in when at 2 position ethyl group is there and the isopropyl group is there. And one another there is a observation is there. That observation is like that. Okay, at this carbonyl, okay, therefore the hydrogen is there, acyl hydrogens, hydrogens is there. Okay, hydrogen shows if there is hydrogen at the bottom, there is no hydrogen present at the bottom. Okay, because valence is complete, therefore this hydrogen is missing. Therefore, if you give the name 1, 2, 3, 4, 5, 6, you found that there is at carbon number 3 and the carbon number 5, the one hydrogen is missing. Therefore, this interaction of that hydrogen with this hydrogen, okay, that is minimized. Okay, therefore, if you given the name beta hydrogen, okay, alpha hydrogen, give the alpha hydrogens. Therefore, in this case, only 2,1,3 diaxial interaction is possible. 3 and that 5. Okay, the 1,3 diaxial interaction is there, and 1 is the 1,3 diaxial interaction at one position gets minimized because hydrogen is not present at this one position. Therefore, one of the observation we have found there, the carbon there is only 2 diaxial interaction is present for alpha hydrocarbon number 3 and the 5, and it misses due to unavailability of hydrogen at carbonyl carbon, there is a minimization of 1,3 diaxial interaction is also found in this molecule. Okay, now we have the alpha halo ketones. Okay, like that we have alpha halo ketones. Okay, at 2 position there is a polar groups is present. Okay, halogens are having the lone pair of electrons. Okay, therefore it is having 6 lone pair. Okay, if it is halogens, it is having the 6 lone pair of electrons. Okay, therefore that is the polar molecule is there. Okay, at the 2 position, okay, 1, 2 position, if there is a polar group is there, then this molecule may when you find this molecule found in more quantity. More quantity means what? This conformation, this molecule found more in this conformation. Okay, therefore percentage wise if you found, its percentage is higher than this molecule. Okay, though there is a interelectronic repulsion. In this case, you found that there are lone pairs and these lone pairs. Okay, oxygen having the 2 lone pairs. These lone pairs and these lone pairs repulsion takes place. And in this case, you found that this acyl is the halogens is there 1, 2, 3. There is a 1, 3 diaxial interaction found there. Okay, though 1, 3 interactions are found there, it is found in mostly in this conformation. In this conformation means your halogens will be at the acyl position. It means the interelectronic repulsion of halogen and the oxygen electron is less than higher than when your halogen is at the acyl position. Okay, by comparing this, when the one molecule is found in a conformation, it means that conformation is stable conformation. Okay, among these two molecules, it takes the conformation where the halogen should be at the acyl position. Okay, when we observe the molecule, first things we have think that there should be the acyl interaction is there. Okay, we think that that molecule should be stable, but actually it is found that the acyl halogen molecule is stable than the equatorial halogen molecules when carbonyl group is two position is there. Okay, therefore it means this inter-electronic repulsion is more than the 1,3 diaxial interaction. Okay, diaxial interaction. In this case, there is an interaction halogen group or polar group, any polar group, halogen group and hydrogen group interaction is less than inter-electronic repulsion. Therefore, in this case, we have found that this conformation is stable. Therefore, among these two conformation, majority of this molecule found in this conformation where we have acyl halogen. Okay, this is all about the stability of when the polar group at the two position to the carbonyl, then the stability you found that if it is polar group instead of polar halogens is you consider halogens, you found that the acyl halogen is a stable halogen. Okay, now if suppose we have to compare we found that there is if suppose there is X is there and that hydrogen, okay, at that 1, 2, 3 position there is hydrogen 1, 2, 3. If suppose that group we give the naming if it is a Y, and second if it is at that is equatorial one and 1, 2, 3 it is at that is your hydrogen. Okay, Y is at the equatorial one. Okay, like that two situations is there. Okay, if Y is the hydrogen, okay, remember, if Y is the hydrogen, if it is 1 and it is second, if Y is the hydrogen, then you found that this number 1 compound is predominant and it is stable. Predominant, it is found in this conformation. Okay, if there is a halogen, X is the halogen is there, and to 1, 2, 3 position, if Y is the hydrogen, then you found that the 1 number compound is stable. Okay, it's like that. And if Y is bulkier than hydrogen, okay, bulkier than hydrogen or other than the hydrogen, any group, bulkier group, if Y is the bulkier, then if Y is the bulkier, therefore the 1,3 interaction increases. Therefore, this molecule or this conformation gets unstable. Therefore, instead of this, it prefers the second number of conformation where this is the bulkier group and this X group, there is an interaction gate, 1,3 interaction gets minimized. If Y is the bulkier than the hydrogen or big than the hydrogen, then this second number conformation is predominant and the stable one, and it prefers the like that conformation where X and the Y are maximum away from each other. And if Y is only hydrogen is there, then it prefers this interaction is the less 1,3 interaction than this repulsion. Okay, then this repulsion, this interaction is less 1,3 interaction is less 1,3 diaxial interaction, that is halogen with the hydrogen interaction is less than this repulsion 1,2 equatorial repulsion. So that's what is the we can conclude that if Y is the hydrogen, then it prefers this conformation, and if Y is the more bigger than the hydrogen, then it conforms this conformation. Okay, like that way we can predict which conformation is stable. When 1,3 position Y, by changing the Y, we can predict that particular conformation is the stable conformation. Okay, now this is all about we have seen in this lecture the conformational effects in a cyclohexane when unsaturation is present, and also we have studied 2-alkyl keto effect, and when at 2 position there is a polar group is there, what is the stability of the particular conformation we have studied in this lecture. I hope you all have get these points. Thank you very much.